how often do we have a small meetup that grows this big? But things have been exciting with CrowdAI over the last 2 years. We started as just a small platform where we wanted to do our own research in an open and accessible way. Now we are still doing that. We have run over 40 or so challenges. We still keep getting requests from both industry partners and research organizations. And just over the last year, we had about 800 gigabytes of user-submitted code and models, which is just amazing. So that's why we basically decided it was kind of time that we took the next step, and we incorporated CrowdAI into a new entity. And there has been a lot of confusion in the whole event on what's CrowdAI, what's AIcrowd. So CrowdAI was started as a small academic project, is now has its new home at AIcrowd.com, where we continue to do the same things with the same spirit. We are still open source and also very friendly to research organizations, and try to do a lot of these state-of-art problems around state-of-art research in machine learning and artificial intelligence. And now, exactly around this time on this stage last year, we made a lot of promises. We pitched a few ideas, ambitious ideas, with many great partners. And over the year, we actually worked very hard on them. And the community also worked very hard on them. And we have a lot of good results. And in this session today, we will be showcasing all the things that we did in terms of the promises we made last year, and then some other interesting things which also came up along the way. And at the end, we will be making some announcements and some new promises for next year, where next year the session will be the AIcrowd session. And without taking a lot of time from many of our speakers, I would want to hand over the mic to Pierre from Humanity and Inclusion. So the context is last year, we were pitching the idea of how we can help humanitarian organizations like Humanity and Inclusion to help understand satellite imagery. I think you'll get a mic there. So yeah, how we can help humanitarian organizations to help understand satellite imagery so they can do much faster and much more efficient disaster response. And Pierre will basically be talking a little bit about his experience.
Thanks a lot, Mohanty.
Yep. You can use this. Okay. 2 clicks. Another one. Another one.
OK, thanks a lot. Good afternoon, everybody. Very impressive to be here. My name is Pierre Gallien, and I am the Director of Innovation Impact on Information for Humanity and Inclusions. Just to make it brief, Humanity and Inclusions is an internal NGO working in more than 50 countries and operating in different types of sectors, such as emergency relief, functional rehabilitation, or humanitarian demining, for example. So I have quite a good experience in terms of humanitarian sector, but I should admit that my knowledge on the artificial intelligence and the machine learning is very weak. So my added value here will not be to comment the technical position or technical resource of the challenge, but to give you a return on experience from an organization point of view. What could we expect and what brings the challenge for us? First of all, the result of the challenge. Well, Mohanty explained the challenge a little bit. First of all, the result of the challenge was far more beyond our expectations in terms of quality. I mean, we were very impressed by the quality of the algorithm developed by the winners, but not only the quality of the algorithm developed, but the level of contribution that we raised in the challenge. It was about 761 contributions. So I would like to warm all of you who contribute to this challenge. It was very impressive and very nice to have that. But from an organization like us, it's more than an algorithm. It was also an opportunity to reinforce the links and to develop some new links with new operation. First of all, with the partners who join us to make the challenge, just like UNOSAT, for example, who provide some source of satellite imagery to do the training set, and with CartoNG to link with the mapping community. CrowdAI is a community, but it was very important for us to link with this mapping community, such as CartoNG, because they are working on the same type of challenge using community approach. And it was also important to tell them that artificial intelligence should be seen as a complementary to a community approach and not rather as a substitute of the community approach. On that, I think we succeed somehow. So we launched a challenge years ago, and there were about 5 algorithms that went on the winner teacher group, and so on. So probably you will have more details about this algorithm. But from an organization like us, for sure, it was very impressive, and it's an added value to have access to such an algorithms because we could not develop them by our own in our own organization. But to give you an image, it's just about if you provide like a motor engines, but you don't have the car. So what to do with that? So it was an opportunity also, this challenge, to raise additional links, additional relationships with organizations such as We Robotics, who are conducting the same type of challenge in the field, and they are using not imagery based on satellite, but they are using imagery on drone, which is more detailed and more precise. So we are conducting a common activity together. And we are in contact also, we raise some contact and we develop some contact with the platform as Picteria. And Picteria is just what we are missing, is just to facilitate the process between the user interface and the image result of the intelligent artificial. So it's very interesting for us that because of the challenge, we have all this community and all this relationship that was able to develop. Of course, we also try to develop the challenge for the humanitarian action is to get access to more satellite imagery at a cheaper price, and we try to get some result by contacting Planet and developing some link with them in addition to UNOSAT. Okay, I'll try to be short, and we keep the contact with GeoNG on the cartography to discuss intelligence artificial. And if we want to be very comprehensive, such a challenge is important for an organization because it was also a way to democratize and to make more sensibilization about intelligence artificial in an organization working on social development more specifically. And basically, the first challenge was supported by the team working on disaster relief management. But doing all this, we were successful to work with other teams, and now we are developing some new ideas, specifically with the mine action teams, and to try to see how intelligent artificial and how analyze of imagery satellite or aerial imagery could bring a shift to speed the release of landmine to the population. So altogether, we are very pleased and I encourage, we have many ideas for a new challenge with crowdAI, and I really would like to thank Mohanty, who are very supportive with our team on this team. There was no challenge possible on all the team of crowdAI for this.
So much, Pierre. Well, while I only facilitated the process, the work was, all the heavy lifting was done by hundreds of our community members. And we actually have 2 of the members of the winning team. And I would invite Piotr and Andre to come in and explain their approach and many of the details. But one interesting bit about their team and their participation was, in many of the classic open competitions around many of these problems, you would see people basically fighting each other out through the whole competition. And these guys started taking part in the competition right from the beginning with an interesting spirit. They open sourced their whole code and asked everyone to easily peek into their code and all their approaches. They also helped everyone pick up really good practices in when you're taking part in these competitions, shared ideas. So the mic is all yours.
Hello, everyone. This is my colleague Piotr. I'm Andrzej. We are data scientists in DeepSense AI, and we are part of the winning team of the mapping challenge. Well, firstly, thank you, CrowdAI and EPFL, for inviting us here. So around a year ago, CrowdAI hosted this competition, and it was basically the first step for building these maps after some natural disasters. We decided to take part in this competition. As you heard, we open sourced our solution. And to our surprise, we won this competition just by a little bit, as you can see, just for 1 of 1,000, right? So the main goal of this competition was to basically find buildings on the maps, and that was what we are working on.
So the task was instance segmentation. So if you think about different challenges in computer vision, you have, for example, image classification, which is like ImageNet to classify if it's a picture of dog or cat. And then you have semantic segmentation when you have to, for each pixel, classify if this is a pixel of a dog or if it's a pixel of a building. And then you have instance segmentation, where you not only have to find the correct pixels, but also to separate them in different objects, in this instance, different buildings. So we used quite classic architecture, which is called UNet. This is a encoder-decoder type of neural network. It's a fully convoluted neural network, and we did some tweaks to it. First of all, we changed the encoder to use very famous ResNet 152. And then it was also pre-trained on ImageNet. So you have this encoder, the first part where the image is downsampled and then upsampled to retrieve the original size. So for each pixel, you get a probability. Like, for example, this pixel is 60% a building. So there are other models like Mascar CNN, but we follow the advice of Russian Kaggle grandmasters who really advise to use this one.
The architecture was actually great. It was performing very well, but there were some fields where it performed poorly. Mainly, the first one was where buildings were very close to each other. Then the network used to connect those buildings, and that was a huge mistake for us. And the other thing is the small buildings. So it couldn't find the small buildings. So we somehow punished our network, right? In such situations, right? So we forced it to focus on the spaces between very close buildings, and also to focus on the very small buildings, so that our score would be improved, and that worked a lot.
And the second very important thing, because we did quite a lot of tricks and tweaks to this model, but a very important one was to use second model. So basically for each image, we produced different predictions from different models, from different post-processing. And then we had another model which was classifying the buildings. So it was like predicting if this building, how likely is it to be matching some ground truth building. So we created a ton of predictions and then had another model that was judging them. And that actually gave us quite a big boost and allowed to take the first place.
So if you'd like to discuss with us more technical details, feel free. And we strongly believe that this was the use of AI for good. Thank you.
You can just pass it along to someone. Next. I think it's Katya. Yeah. Okay, thank you, Andrei and Piotr. Much of the community still keeps coming back and referring back to their overall spirit in taking part, and the code that they basically developed for image segmentation is still actually used as a reference across many different such image instance segmentation challenges. Now, this will be a roller coaster of many interesting short talks across many various different problems. Now, I will simply hand over the mic to Katya. She will be talking about Minecraft.
Thank you, Mohanty. Thank you for inviting me to be here. It's my huge pleasure and honor to give you an introduction to the Marlowe competition that we ran in the past year, as well as, very excitingly, announce the winners of this competition. I'm also very excited to let you know that while we ran the first competition last year and are able to announce fantastic winners, the competition that the challenge that we posed in this competition is far from solved. So if you are interested in reinforcement learning and generalization to multiple tasks or agents, then do pay close attention, because who knows, maybe an idea for a breakthrough will come from you and your team. I organized this challenge together with a fantastic set of collaborators from EPFL, Queen Mary University in London, crowdAI, and Microsoft. And across this team, we share the excitement and passion for reinforcement learning, as well as understanding what, in particular, modern video games can do, both in terms of pushing reinforcement learning research to tackle more and more interesting challenges, but also in terms of applications that could eventually be opened up, both in video games and other real-world settings. So if you're not very familiar with reinforcement learning, here's a very, very quick introduction. Reinforcement learning is a type of machine learning where an agent learns not from a fixed set of data, as you do in supervised learning, but directly from interacting with an environment. So for example, in this task illustrated here, an agent would need to understand and take some actions in this environment and then learn to figure out that moving towards this pig is maybe a good thing to do, and that in particular it will get a high reward when it manages to corner and catch the pig by collaborating with the other agent in this environment. But so in reinforcement learning, this is not known to the agent ahead of time. It has to figure that out through interaction with the environment. Now, with a lot of data and deep neural nets as a function approximator, we know that reinforcement learning can be very powerful and learn very good performance on individual tasks. But a key challenge is to understand whether reinforcement learning agents can actually learn to generalize. Can they generalize to even minor variations of a task? For example, when the mob that it has to catch is a cow instead of a pig, when there are different lighting or weather conditions, or a different setup, as in a different arena, different materials, and different collaborating agents. And these kinds of examples illustrate key challenges in reinforcement learning. I'm illustrating them here in this game setup, but if you imagine you have to relearn how to brush your teeth every time you buy a new toothbrush, then you get a good idea of what the current state of the art in reinforcement learning is and why it is so important to push towards more general approaches that can generalize to variations of tasks and different settings. Now, the organizing team, we decided to use Project Marlowe as the platform to build this competition on top of. Minecraft is a fantastic environment for a challenge like this, because as an open world game, you can create infinitely many tasks, infinitely many variations for the agents to tackle. Minecraft, this platform, Project Marlowe, is a platform built by my team at Microsoft, and it's open source on GitHub, so this is something you can try out today. For the task and game setup, we decided that we'll have a proper setup for testing generalization. So the agents were trained on instances of 3 games that were available during training. They could then submit their solutions and compare to other participants on the crowdAI platform, but they were finally evaluated on a set of held-out test instances that were not seen during training. And the competition, there was a final tournament held on the crowdAI servers in order to determine whether the submitted solutions could actually generalize to those new tasks. Just to give you a quick sense of the kinds of tasks we had our agents tackle, you can see here the 3 types of games. Mob chase, where agents have to collaborate to catch pig, chicken, or other mobs in a small enclosure. A treasure hunt, where agents have to collaborate, one collecting treasure, one protecting from zombies. And a build battle, where agents have to collaborate to build a structure. You can also see for the mob chase some of the variants that we gave the agents in order to test whether they could generalize to those new instances. With that, I hope I gave you a very quick but hopefully informative overview of the competition, as well as a sense of why this is a really hard task. And I'm now very, very happy to announce the winners of the 2018 Marlowe competition. The winning team is a team from Bielefeld University in Germany, Andrew Melnick, Leonard Bramlage, and Henrik Voss. And their approach was to use mimic states, an approach where they recorded human players tackling some of those challenges, and where they would then use an agent that would match the kinds of situations with the kinds of situations in which people had acted in a particular way. The winning team will receive $10,000 in Azure credit so that they can further their research. as well as student travel grants to a leading machine learning conference. We also have 2 runners-up and 2 honorable mentions. The runner-up is a team from New York University in the US, consisting of Rodrigo Canan, Philip Bontrager, and Michael Green. They will receive $5,000 in Azure credits, as well as a student travel grant. The second runner-up is Linjie Xu from Nanjing University in Shaanxi province in China, and he will receive $3,000 in Azure credits, as well as a student travel grant. And last but not least, we have 2 honorable mentions, which I'm showing the team names here, Omuram and Karina Isi from University of Tokyo, and they will be receiving student travel grants as well. So let's give all of the winners a round of applause. So what's next? The Marlowe 2018 competition is closed, but you can still access a lot of material on the crowdAI platform. You can see a description of the challenge tasks which we just posted to archive, and you can access the Marlowe starter kit and tasks on the URL shown here. So if this is an area that you're excited about, if you would like to try your ideas and see if you can push the state of the art in the very, very hard challenge of multitask and multi-agent reinforcement learning, then I would very much like to encourage you to go online, check out these resources, and see how you can bring your ideas to life. To conclude, I want to leave you with a set of resources. For example, if you have never tried Project Malmo, you can easily go online and check out the instructions, tutorial, and code from GitHub. There's also a fantastic community of enthusiasts and researchers which are very active in the Skitter channel and can help you get started. I would like to thank the crowdAI organizers for being such fantastic partners in this challenge, and I'm looking forward to see what new and exciting challenges on top of Project Malmo will be seen in the future. Thank you so much for your attention.
Yeah. As easy and fun it seems to kind of play with Minecraft when you have to train agents which have to kind of collaborate and compete across a variety of tasks, it is actually quite difficult. And we spend like many sleepless nights trying to both set up the environment, train agents, and whatnot. And the task itself is very hard. And with challenges like these, we do want to kind of set across many of these open benchmarks, which can help us measure our own progress very objectively across the years on how much progress are we making in all the promises we make across reinforcement learning and many other such domains. But now, many of you basically took your trains to reach here, and all of them were magically on time. The Swiss National Railways, they're always on time. But now, I would actually invite Julian, who would be talking about the train schedule optimization challenges and how does it take to have perfect schedules, what does it take to have perfect schedules and trains never be late. Thank you so much.
Thank you, Mohanty, for the introduction. So my name is Julian. Left is next, right? Oh, okay. Yeah, my name is Julian Jordi. I work in the software development team at SBB, the Swiss Railway. And it's also my great pleasure to give a short summary about the train schedule optimization challenge we did last year, how it came into being, what we did, why, and how satisfied we are with the results and what's possible with a platform like crowdAI. So SBB right now is sort of in a process of reinventing itself. And nowadays, if a company of reasonable size reinvents itself, it's always called something 4.0. And we are no different. So there's a huge program, Smart Rail 4.0, where basically the whole infrastructure and also the software layer that manages all the trains will be completely reinvented. I don't have time to go into details. You can check the website if you like, but one important part of that program is we want to automatize the timetabling and rescheduling. So what does that mean? Nowadays, timetables are sort of drawn by hand, which means timetable would draw their trains on these diagrams, and they see, oh, okay, this might work out. This train I have to pull down a little so it won't block the others to an entry. And then in the end, we hope that it works out in practice. And what we want to do in the future is you basically describe trains in terms of their commercial requirements, which means you collect the earliest departure times you want and the latest arrival times, and maybe the connections they have to keep. And when you gather that, you get for each train sort of a band of flexibility where it could conceivably be scheduled in detail afterwards. And that's what you see on the left. So the vertical axis is time, and the horizontal axis would be space. And within these blue bands, you could conceivably schedule the trains. And the task is, of course, to do this conflict-free, so that when these actually would run like you scheduled, then no resource in your tracks would ever be blocked by 2 trains at the same time. And so that's the task that our group basically has to build a system that takes input like that, puts it into solvers, or many different kinds of solvers, we don't care, that maybe compete against each other. And in the end, we want for each train, for each blue band, we want a precise schedule where precise precision to seconds time is assigned to each event, and so that no conflict results. Now, this problem is basically a variant of the job shop schedule problem, so it's well known, and job shop schedule problems have been studied to death by the literature. So why do we do a challenge? Basically, the problem is always scaling, and it's also suitable. There should be. So basically, the challenge for that we set out was we asked the solvers, the crowdAI solvers, to come up with this question mark there. So a solver that takes the input and produces the schedule. And why do we choose this path of crowdsourcing? So we have internal developments that also build such solvers, competing with the crowdAI solvers, but we wanted to get a global reach. So basically, we know what the academic literature is about this problem. We implement solvers that are described in these papers, and typically they use commercial solvers like Cplex, MILP solvers, and similar stuff. And we just wanted to broaden the horizon. Well, what other approaches could there possibly be? Could there be AI approaches which have so far really hardly ever been tried on this problem? So one of the reasons is we want the global reach. And related to that is we want people to go off the beaten track. We tried to solicit ideas that had never been tried before, because in the academic world, usually it's the usual suspect. So the PhD student will build on something that the professor did before. And so you get sort of, the genetics are not right. You never really spread out. So that was one important reason. And also, last but not least, for a company like SBB, it's a good platform to showcase our interesting problems. Because I don't know how many of you think that for, say, software developers or data scientists, SBB is an interesting place to work. It actually is. I could tell you from first hand that I don't think there are 5 people in this room that have a more interesting job than me. But for, like in the talent war nowadays, it's really tough. So you have to compete with the likes of Googles and Amazons. And if you rather make sure times are on train, then recommend the next YouTube video. So then you can give us a try. So how happy are we with the results? What is possible on such a platform? So let me say that the performance of the solvers that were submitted on the instances that we published for the challenge were better than our internal solvers. So it's not so surprising, because don't laugh, but for this challenge, the training set was actually the test set. There were reasons for that, technical and time limitations, but still, nonetheless, they were hard problems, and the solvers solved them better than our internal global solvers. And also, what we did achieve was we got a whole zoo of different approaches. That's exactly what we wanted. So we had, in the first top 10, maybe we had people doing it in 400 lines of code using some standard API of Google Open OR solver, all in 400 lines of code. And we had people, the very best people, that used completely handwritten heuristics, which worked extremely well on these instances. So we had this variety which we were looking for. And two subgroups in particular that struck our interest was the top guy is the greedy algorithm. So these are algorithms, heuristics that will just make decisions and run with it and hope it turns out well. And because it's not a generic job shop schedule, but actually there's a lot of business logic you can use when you schedule trains. So if you build smart heuristics, you have a good chance to reach a feasible schedule in the end. So that's the top one. That's a group that was really successful. I think the top 3 all did that. And then the second group is artificial intelligence approaches, which I mentioned already before, have so far never been tried. I think there are like 3 papers in the literature that sort of go into direction that in the direction that we need. And there's plenty more stuff to be done there. There was one solver, I think 6th place, that used a approach that was so crude it couldn't possibly have worked, but it sort of did. And it was quite good. So, and if you're interested in that, please stay tuned. My colleague Eric, in just a few minutes, will announce some new opportunities in that area. And then what turned out to be a little difficult was actually implementing these solvers into our system. Not because they were bad, but because the rules changed during the challenge. So that's a lesson learned that if the problem changes during a challenge, you cannot just take it one-to-one and plug it into your system. We knew that. We were not surprised by that. We didn't care because the basic ideas still stand. We can use those. But of course, our manager wants to know when can you plug it in and stuff. So that's something you have to keep in mind. Yes, so thank you very much. Let me finish by, first of all, thanking all the participants for the hard work and for the CrowdAI team for their support. And wish you all success with your new name, AIcrowd. Thank you.
Thank you so much, Julian. Organizing many of these challenges is like really hard work, and usually that's not something which comes across. But in case of Julian, as in you would be surprised how much work he put in setting up the challenge, through the whole challenge and supporting participants, and at the end, dissecting the code submitted by participants to understand what exactly happened and how we can improve the whole thing. So congrats, Julian. And we'll get back to SBB again really soon with Eric talking about some new things which came out of this one initial challenge. But before that, I will jump back to Bob and, yes, I'll jump back to Bob. This small jumping skeleton in a simulated environment that we talked about last year. This is a small skeleton which lives in a simulated environment, and the goal is you are supposed to send signals like a puppeteer to the lower part of the body and teach it how to walk, run. And last year, we ran a pretty successful challenge, and we presented some of the results here. And this year, so this is what Bob was doing kind of last year. And this year, we were a little bit mean. We associated with the same conference, NeurIPS, and this time we cut off one of Bob's legs and put in a whole prosthetics. But then that was with a purpose to understand how we can basically simulate how your gait is affected because of surgical interventions. So we ran a pretty big competition around that at NeurIPS this year. And I will invite Sergey to come in and present his results. He's third again this year. He was last year third and also presenting his solutions. And he will be talking about his solution and his experience with the whole competition again. I will just move Bob across. There you go. Thanks.
All right. Oh, yeah. So, hello, my name is Sergey Kolesnikov. I am working as a senior data scientist at startup DeBrain, and as my hand said, I am here to present my solution for AI for Prosthetics challenge. So, but before I start, I would like to grateful the whole team of CrowdAI and AMLD team, because it's my second time here, and I really appreciate this opportunity to still come in Switzerland and, you know, participate in this conference. So, yeah, the goal of this competition was to enable a physiologically-based human model with a prosthetic leg to walk and run. Model performance were ranked dependent on the ability to adapt to changing target velocity and direction. So, rather than just running one direction, you need to adapt for different directions and velocities. So, participants were provided with a physics-based simulation. So, and were proposed to use a reinforcement learning framework to prepare this model. So, we need to predict an optimal action A. This is muscle activations of the skeleton based off its observation of its environment to achieve some reward R, something like how we are good enough in this walking and running competition. So, to make this done, we use all recent advantages in deep reinforcement learning, like TD3, quantile regression networks, distributed training, different hybrid exploration techniques, and combining all this theory together, we come up to something like practical solution. We developed our own reinforcement learning framework with all major reinforcement learning implementation algorithms and feature supports like distributed value function, something like distributed training, and all the stuff. So nowadays it's all open source and powered by PyTorch, so you can easily use it. So additionally, we proposed llama pooling, which stands for last average max attention pooling. It's like an efficient way to handle several temporal observations in one singular state with the purpose of attention mechanism. So, in the end, we went to our solution that in this particular competition was quite robust and, which is much more important, really sample efficient and give us huge final reward. As you can see, we use just one GPU and 24 parallel CPU, so it's really cheap setup for reinforcement learning competition, but still we have these really quite good results. So yeah, additionally we have some improvements to make our model even more robust, something like task-specific models, checkpoint ensembling, and action mixture. As you see, it boosts our performance a lot. So in the end, wow, yeah, is the video. So yeah, it's our guy. It's fully robust, so it uses these prosthetics like a stick to just move and move. Oh, thank you guys. Okay, so afterwards, I really appreciate this competition because after the end of this competition, our team decided to just gather all our machine learning expertise and create the Catalyst. It's our framework for fast and reproducible deep learning and reinforcement learning experiments. So give it a try and, I don't know, send me a review and your experience with it. So additional links if you are interested in, and that's it. Thank you for your attention. You know, if you have any question, I would be ready to talk. Thanks.
Give it to Eric. Yeah. And the clicker. Okay. It'll be just next time. All right. Thank you, Sergey. In fact, the last library Catalyst that he mentioned, and that was one of the outputs of his participation across both the challenges on this particular problem, which is now a very flexible reinforcement learning library, which if you play around with reinforcement learning, I would also personally strongly recommend Catalyst. Now, moving on, we were supposed to present this, which was one of the NeurIPS competitions this year, and but in the interest of time, I would just encourage you guys to kind of check about this on the platform itself. But the overall context of this particular challenge was, in a world dominated by AI, the whole notion of hacking a particular technological solution can be as simple as putting a sticker on a stop sign, which confuses your autonomous car to believe that this stop sign is not a stop sign, but a speed limit of 90 sign. So where things can go wrong. So in this particular series of competitions, along with NeurIPS, we set up a way in which participants could contribute both models and attacks, and all of these groups of participants would compete together so that the overall quality of both attacks and models evolve together. But now, again, not spending much time here, I will actually get back to SBB again on some really interesting stuff, again, about reinforcement learning that came out of some initial discussions with SBB and some random throwing of ideas at each other. So, Eric. Flatland.
Thank you, Monty. So I liked your comment before that the trains in Switzerland by some magic arrive on time. It's actually not magic. And actually, we're asking the crowd to help us invent the magic of the future that will keep the trains on time in future. So it's a collaboration, again, with now AIcrowd and SBB. And the first challenge was about how to make good schedules for different needs of customers. But then when you have the schedule, you still need to manage the traffic so it stays on time. So I'll give you a short video to introduce you to the complexity of the problem. So what you're seeing now is a simulation that we have built that is simulating the full Swiss railway network and the traffic. And if you pay close attention, you will see that not all the dots are moving at the same speed. And that's the huge problem. Because they're not moving at the same speed, we need to somehow organize the traffic such that we don't get congestions and that trains run smoothly. We have, as some have heard of you maybe earlier today, between 10 and 15,000 train runs a day. And we have about 13,000 switches and 30,000 signals that we have the ability to use to manage our train traffic. So that's the complexity of the problem. Somehow we need to manage this. Today it's humans doing this with support of computers, but in future we actually want smart AI trains, so we want them to do it themselves. That would be a goal to offload the problem from us humans to the machines. So what's the problem? The problem is when we have different trains, they run through all of Switzerland, and some of them don't have any interaction points, so they are quite easy to manage. But sometimes they do interact, and there is decisions needed to be made. These decisions now should be made in a multi-agent cooperation, that's what we believe. So let the trains together cooperate to find the best solution how traffic should run on the railway network. And this is why we're launching this Flatland Challenge next year, or this summer, sorry. And this is the early alpha version of this. We're building on the complexity still. What you see on the left side is the agent states. The agents locally observe the railway network around them. And on the right side, you actually see a simplified railway network with agents. And as you can see from some examples, they're not very clever yet. And that's why we're asking for the help of the whole reinforcement learning community and all AI researchers across the world to find some new approach and algorithms that can actually lead to multi-agent cooperations on railway networks or any transportation network. So if you're interested, stay tuned. Coming on July 2019, together with AIcrowd. Thank you very much.
Thank you so much, Eric. Usually when we are deciding on a challenge, traditionally how it would happen is another research organization or a company would come to us, then some members from our team would sit with them and we would just play with the data and or the simulator, and we'll come up with something, just some initial baselines and a problem definition. But in context of this, well, while we started by playing with the whole problem ourselves with Eric and a few others from SBB, we recently opened up this whole formulation of the problem to our community, and we had an overwhelming response. And if any of you are interested in reinforcement learning and want to help optimize the Swiss train schedules through reinforcement learning, you guys, please feel free to reach out to us and help us in establishing this, both as a benchmark for multi-agent reinforcement learning and also for optimizing the trains. Now we are a little bit late on time. I see this beeping. So we have another quick announcement, and that I will skim through actually. So the overall context is, again, in reinforcement learning research, you have a lot of these classic games which suddenly until a particular point become very hard to feasibly solve. Montezuma's Revenge was one of those games which was used as a benchmark to see how good, in general, the rest of the community is, or where we stand in terms of reinforcement learning. But that was also, to some extent, solved just earlier last year. And now, in search for new problems, we are kind of collaborating with Unity to launch another series of such benchmarks, the first one of which is called as Obstacle Tower. Now, Unity, if you know about it, is this game engine with which pretty much most of the 3D games that you play with are designed. And this has a lot of advantages like really high-fidelity 3D visuals, real-time lighting shadows, flexibility in terms of designing your own environments, and many other such features. And we want to introduce these set of tools to the community of reinforcement learning researchers so that they can design a lot of series of different kinds of tasks on which the rest of the community can test out their algorithms, and we get a better sense. So for this particular competition, again, it's like a obstacle tower game, classic one, where you have to go around and solve this whole puzzle. And in context of reinforcement learning, the observations that you get are single frames, pretty much like what humans would see. And the actions that you can do on this environment are the operations that a human can basically do, like move around, look around, and stuff like that. And finally, the rewards are just one reward mechanism that we impose for the evaluation. But again, when you are playing with this, then you will definitely have to come up with your own creative ways to define the reward. This is something which is starting soon, like really soon. And so you're welcome to sign up on AIcrowd.com. And we'll be sending out updates on these and a few other really exciting challenges which are coming up. Now, the final concluding remarks, before I put out a larger call for AIcrowd community beers, I would call Marcel to say last few words for the concluding session.